So this is the 2015 Leaving Cert Higher Level Paper 1, and we're looking at question number 3. Let f of x equals minus x squared plus 12x minus 27, where x is an element of the set of real numbers. Part A1 says complete table 1 below. So we have table 1 here. We've got our x values going from 3 up to 9, and then we have to fill in our f of x values. So some of them are done. So all we're doing to find these f of x values is we're replacing the x in the function with the x value. So if I put 5 in this function up here, I would get minus 5 squared plus 12 by 5 minus 27. And the value I would get, you can do this on your calculator. You can use the table function if you like, or you can do each value individually. But just to be clear here, I'm finding f of 5 for the first one is equal to minus 5 squared plus 12 bracket 5 minus 27. And when I put all of this here into my calculator, I get a value of 8. So we're going to do f of 6, f of 8, and f of 9 in the same way as we did these here. And when we do that, we get a value of 9 for f of 6, a value of 5 when we put in 8 for f of 8, and finally we get a value of 0 when we put in 9. So that's the table completed. And now part 2 says use table 1 and the trapezoidal rule to find the approximate area of the region bounded by the graph of f and the x-axis. Okay, so I'm just going to draw a small little sketch here of this function. And now the first point is at 3, 0. So we go to 3, 0, so that's 3, 0. And then the function goes up to 5, 4, 8, 5, 9, 6, 8, 7, 7, 8, 8, 5, back down to 9, 0. So the values, because it's quadratic, it's going to be going like this. And it's finishing here on the x-axis at 9, 0. So you can see the high point there is going to be the value 6, 9. And this is just a sketch to show you that we're finding the area under this curve between the curve and the x-axis. In other words, this. So we're looking for this area in here. So the trapezoidal rule is a rule that's in your tables book. I've taken it out here, and it's used to approximate, which you can see from this wavy equal sign, to approximate the area under a curve. Okay, so we're going to plug some values from the curve into this trapezoidal rule. So our h value here, h is the divisions across the x-axis. So we can see our x-axis is going up in 1 every time, up by 1. So our h value is going to be 1. That's going to be our h value. Then y1 is the first height at the beginning of the curve, which in our case is 0 because it starts from the ground. Yn will be the last height, which is also 0 because it finishes right down on the ground or the x-axis. And then it's plus twice all of the heights in between. So these y values are the heights up along the y-axis. So in our case, this is y1. This is yn, the last y value, and all the other y values are the ones in between. So that means our area, using the trapezoidal rule, will be h over 2, which is 1 over 2, bracket y1, which is 0, plus yn, which is also 0, plus twice all the heights in between, so the addition of them. 5 plus 8 plus 9 plus 8 plus 5. So when we put all of this here into the calculator, we get a value that is 35. So because they asked us for an approximate area, that 35 is going to be in units squared, because we're not told if it's centimeters or meters or anything like that. So 35 units squared is the answer. Part B1 says find the integral of f of x dx between 3 and 9. Okay, so the integral between 3 and 9 of f of x. Now our f of x was given up here is minus x squared plus 12x minus 27. So it's the integral of that function, which I'll put in a bracket, dx with respect to x. So now I'm just going to integrate this polynomial. So by integration, that's going to give me the integral of minus x squared is minus x cubed over 3. And the integral of 12x is 12x squared over 2. And the integral of minus 27 is minus 27x. So that's the function integrated, but remember it's between 3 and 9. So we're now going to substitute the 9 value in for x here, here, and here, and work this out. So when I put the 9 in here, I end up with minus 243. Again, doing this in the calculator, when I put 9 in here for this second term, I get plus 486. When I put 9 in for this x, I get minus 243. So that's the function when I substitute 9 in, and from that I'm going to subtract the same function with 3 substituted in. So it's important to do this out. Don't try and do this in too few amount of steps. You want to take your time with this to account for the negative, and make sure you protect the second substituted function with a bracket. So minus, when I put 3 in for this x, I get minus 3 cubed over 3, which gives me minus 9. Plug it in for the second term rather, and I get a value of 54. And finally substitute the 3 in here, and I get a value of minus 81. Okay, so now I can put all of this into the calculator in one go, and that gives me an answer of 36. So there, I've integrated the function now with respect to x, and the answer is 36. That's B part 1 finished. B part 2 says use your answers above to find the percentage error in your approximation of the area correct to 1 decimal place. Okay, well, if we go back, we know the approximation of the area was 35 units squared. And then what did we do in part B1? We integrated the function with respect to x between 3 and 9. Now 3 and 9 happen to be the points where this function crosses the x-axis. And we know that integrating a function finds the area of the function the area between that function and the x-axis. So what that means is our answer of 36 is the exact area under this curve between 3 and 0 on the x-axis. So we know the exact area was 36 and our approximation was 35. And part 2 is asking us to find the percentage error in the approximation. Okay, well, because the exact area was 36 and our approximation was 35, our error then was 1 unit squared. So that's our error. However, they want the they want the percentage error. So if you have the error, to express it as a percentage, you're just going to put the error over the area over the correct amount, which was 36, and then multiply by 100 to express as a percent. And so if we do that in our calculator, we get we get 2.7 recurring, and they've asked us to give it to 1 decimal place, so that would be because 7 recurring is 777, it's 2.8. So our percentage error is 2.8%, correct to 1 decimal place. And that's the end of question number 3.